Hey everyone, welcome back to another explainer. Today we're unpacking a really fascinating piece of the networking puzzle, the User Datagram Protocol, or as it's known pretty much everywhere in the tech world, UDP. If you spend any time working in cloud networking, systems architecture, or application development, you already know that UDP is the absolute go-to for fast-paced, high-speed network communication right at the transport layer. I mean, it doesn't wait around, it just goes. So today we're going to map out exactly what happens under the hood on both the client and the server sides of a UDP transaction. And we'll be using some incredibly clear visual breakdowns directly from our source materials to guide us. Okay, let's dive right into this. Here is our roadmap for today. First, we'll look at the connectionless protocol. Then, we'll break down the client-side actions, followed by the server-side actions. And finally, we'll wrap up with the catch, which is all about having no guarantees. Starting us off with Section 1, the connectionless protocol, where there are absolutely no handshakes required. So, by strict definition, a connectionless protocol means communication where there's no formal handshake, zero session setup, and the server literally doesn't even know about the client in advance. Think of it like sending a postcard through the physical mail, or, just shouting a message into a really crowded room. You aren't tapping someone on the shoulder, initiating a polite greeting, and waiting for them to say, "Hey, I'm ready to listen," before you actually speak. You just formulate your message and fire it off. Because of this, each and every UDP packet is completely independent of the ones that came before it and the ones that are going to come after it. Let's move on to Section 2, Client-Side Actions, the Launchpad. All right, so here we have the complete step-by-step lifecycle from the client's perspective. Let's look at this as a kind of micro-narrative of a sender packing up a box of data. Step 1 is socket creation. Obviously, the client has to create a UDP socket to even kick off the process. Step 2 is binding to a specific local port. Well, actually, scratch that. This step is totally optional. It's not mandatory in UDP for the client to bind to a local port. Step 3 is packing the box. Data preparation. This could be a message, a packet, whatever data you're transmitting. Then we hit the absolutely critical event, Step 4, sending data. The client uses a specific function called sendto, designates the exact destination IP address and port, and just launches it. Steps 5 and 6 show that the client can optionally set a timeout value, just in case the server ghosts them and never responds, and set up some basic error handling. But the core action here, it's simply packing that data and launching it toward a destination without ever waiting for permission. Which brings us to Section 3, Server-Side Actions, the catching mitt. So, if the client is the launchpad, the server is essentially a massive warehouse keeping its loading dock wide open. Just like the client, it kicks off with socket creation so it can receive data. But right here, in the second step, binding to a port is essential. The server absolutely must bind the socket to a specific port so it actually knows where to listen for that incoming data. Then we hit Step 3, waiting for data. The server enters a continuous loop. It's really just sitting there, actively listening with its catching mitt wide open. When a packet does eventually show up, we get data reception. It catches the data, and crucially, it also captures the sender's address. From there, it jumps into processing data based on whatever your application logic says to do. Interestingly enough, sending a response back to the client, entirely optional. The server might just ingest the data and call it a day. It handles any errors, and when it is completely done listening, it can optionally close the socket down. And this brilliantly illustrates the whole dynamic between the two ends of our network communication. We have the client sendto function. That's the active launching mechanism dictating exactly where the data goes by specifying the destination IP and port. And on the flip side, we have the server's recvfrom function. This is the passive yet continuous waiting mechanism that catches the data and grabs the sender's address the second it arrives. It perfectly encapsulates that connectionless relationship, right? One side pushes independently while the other side loops and waits to receive. Let's wrap things up with Section 4, the catch, no guarantees. Because there is no formal handshake or session setup whatsoever, every single UDP packet is a lone wolf, totally independent. There is absolutely no acknowledgement of receipt baked into the protocol itself. If a packet gets dropped by some busy router along the journey, the UDP protocol is not going to tell the client, and the server won't even know it missed anything. It is a fire and forget system in the purest sense of the phrase. So the crucial point to take away here is this. The application layer is the one that must handle lost or out-of-order packets. UDP strips away all that heavy overhead of checking, rechecking, and verifying data purely to give you raw, unadulterated speed. But because it doesn't guarantee reliable delivery, the heavy lifting for error correction falls entirely on your application logic. If your software absolutely needs to know a packet was lost, or if it has to reorder packets that showed up out of sequence, you, as the developer, have to build those mechanisms into the application layer yourself.
Which leaves us with this provocative thought to wrap up our explainer today. When would you actually want to use a protocol that simply doesn't guarantee delivery? I mean, it sounds kind of counterintuitive at first, right? But think about real-world scenarios where raw speed and an open pipeline are way more critical than perfect, flawless reliability. Think about your live video streaming or voice over IP calls. If you had to wait for a dropped frame or a lost syllable to be resent, it would cause these massive, annoying delays. Or think about fast-paced multiplayer gaming. Your character's position a full millisecond ago matters way less than getting the newest coordinate right this second. UDP is a remarkably powerful tool precisely because of how lean it is. You just have to know exactly when and how to leverage it. Thank you so much for joining me for this breakdown of UDP. And as always, keep on learning.